So in this problem, we're being asked to find the formula of a compound given its percent composition. So this is also known as elemental analysis. So from the relative percentages of each element that are present in a compound, we're going to try and figure out what the formula of the compound is. Remember, a chemical formula is the ratio of the atoms in the molecule. It is also the ratio of the moles in that compound. So we need to get moles of each and then turn that into a whole number ratio. So here's the original question. We have 3 elements in this particular compound, and we are 38.8% calcium, 20% phosphorus, and 41.3% oxygen, and we're asked to find what is the formula of this compound. So the first step is to assume a sample size, because we can technically assume any size sample we want to. We're going to pick 100 grams just because that makes our math a whole lot easier. But this method technically would work even if you picked another sample size. You just would have to multiply your sample size by each of the percentages. So if I pick 100 gram samples or size, then it's easy because you're just multiplying each of these percentages by 100. And so 38.8% calcium means you have 38.8 grams of calcium in that 100 gram sample. So again, the chemical formula is the molar ratio, so we need to take each of these masses and turn them into moles. So to go from grams to moles, we divide by molar mass. So I'm going to take each of these and I'm going to divide by their molar mass from the periodic table. So for calcium, that's 40.08 grams per mole. And then the same thing for the other two. So again, when we start with mass, grams, and we divide by the molar mass, which is in grams per mole, grams will cancel and we'll be left with moles of each. So now we have moles of each, but we need this to be in a whole number ratio. So the best way to get to a whole number ratio is to pick whichever of these is the smallest amount. In this particular example, it's the 0.646 moles of phosphorus, and we're going to divide all of them by that number, which means that we would end up with 1 phosphorus and then something equivalent of the other elements. So I'm going to take each of these, I'm going to divide them each by 0.646 moles. Now when I do this, I'm going to go ahead and round to the nearest whole number or fraction. So if you're not getting very close to a whole number, I mean within one tenth of a whole number pretty much, then round to whichever fraction is nearest. For example, 0.968 divided by 0.646 gets you something about 1.49, which is pretty close to 1.5, and 1.5 is the fraction 3/2. So I'm going to write, instead of a whole number for this one, I'm going to write that as the fraction 3/2, calcium. And then I end up with 1 phosphorus and 4 oxygens. So now here's my molar ratio, but we want to need this to be in a whole number ratio. If these all ended up being whole numbers, then you're good and you're done. But in this case, it didn't. We have a fraction, and we do not want a fraction for one of our elements. So what we do is we take the entire ratio, and we're going to multiply by that denominator to bring it up so they're all whole numbers. So in this case, the denominators are 2. So I'm going to take everything and multiply them all through by 2. So when I do that, 2 times 3/2 will give me 3 calciums. 2 times 1 is 2 phosphoruses. 2 times 4 is 8 oxygens. So now I have the whole number ratio of each element, and I'm ready to write this as an empirical formula. So this is calcium with a subscript of 3, phosphorus with a subscript of 2, and oxygen with a subscript of 8, like that. So here is your empirical formula. The term empirical means from an experiment, so this may not necessarily be the molecular formula. Now in this particular example, we have an ionic compound because calcium is a metal, so we always report the empirical formula anyways. But if this has been a molecular compound, the empirical formula is going to be the most simplified lowest whole number ratio of each element, which may or may not be the same as its molecular formula. So here's your empirical formula, and for this particular problem, we're done.